Calculate the mass of copper deposited when a current of 0.5 ampere was passed through a solution of copper 2 chloride for 45 minutes in an electrolytic cell. We have that Cu, the copper here is 64, while the Faraday is 1 Faraday is 96,500 coulomb. Now let's go. Before we go into this, I want to talk about one or two things about about the law guiding this. This is talking about electrolysis. This is what? Electrolysis. So, and without these laws by Michael Faraday, first law and second law of electrolysis, you will not be able to understand this. So now let me state briefly what the law is talking about. Faraday's first law of electrolysis is trying to let us know that the mass of an element that is discharged during electrolysis is directly proportional to the quantity of electricity that is passed through the electrolytic cell. Now, that means as the quantity of the electricity increases, the mass of the element deposited or discharged also what? Increases. Now, the second law is telling us that that quantity of electricity we are talking about, that if the same quantity of electricity is passed through different electrolytes, that the number of moles or the moles of this element deposited is inversely proportional to the charges on the ions of the elements. So that means if the charge of the ion of the element is, let's say, +2, and we have another one that it has +1, that the moles of this element that is deposited is inversely proportional. So the one with, let's assume now that we have copper and the silver. Copper is +2, silver is +1. So, and let's assume that the number of mole is X. So silver will be 2X, while copper will be just X. That's what the second law is trying to let us know. So if you look at this question is a combination of the two laws of Faraday. We need the two laws for us to be able to answer this question. Now let's go on getting to looking at this question. Now there is already an electrolytic cell containing copper 2 chloride as the electrolyte, and we have the anode and the cathode. Now the electricity that was passed through it goes like this current of 0.5 ampere for 45 minutes. Now copper will be deposited to the at the cathode, but they want to know the mass of that copper that will be deposited at the cathode. Now, from the first law, M is directly proportional to what? Quantity of what? Q. Quantity of what? The electricity. And Q here, which is certain, I say that M is directly proportional to what? IT. Because Q is what? IT. Q is what? IT. Which is what? Current times what? Time. Current times what? Time. So the first law is covered already. Now, but we now want to look into something. You know, in the electrolytic cell, The copper there exists as copper 2 ion. And for it to be deposited at the cathode, it has to take up what? Electrons, right? For it to be what? Reduced. So it take up what? Electron. And it can only take up 2 molecules, 2 moles of what? Two electrons. For it to be deposited as what? As what? Copper solid at the what? Cathode. This is aqueous. Now this can be said, there's this relationship between, it has been established that 1 mole of electron is the same thing as what? 1 Faraday. So here now we have 2 electrons here. So the same thing as what? 2 what? Faraday. And this 2 Faraday is responsible for the position of 1 mole of this copper at the cathode, which is can be represented with the what? The weight of 1 mole, which is what? 64 what? Gram. So what it implies is that 2 Faradays of electricity deposited 64 gram of what? Copper at the cathode. We are arriving at somewhere. We are arriving at what? Somewhere. All right, let's go. Let me clean up from, okay, let me take up the parameters before I can clean. The time is for 5 minutes. The current is 0.5 ampere. I remember 0.5 watt ampere for 5 minutes. Now 2 Faraday we do what? Deposit 64 what? Gram of copper at the cathode. Now remember that 1 Faraday is what? 96,500 coulomb. It was given. So that means 2 Faraday is what? 2 times 96,500 coulomb of electricity deposited what? 64 gram of copper at the cathode. But we are told, remember I said that Q is equal to what? IT. This is the quantity of electricity. It's what the current times what? Time. And the current that was given is what? 0.5 watts ampere times time. Time is what given in 45 minutes. So we convert it to what? Seconds. 45 watts. 45 minutes. But there are 60 seconds in 1 minute. So in order to convert this 45 minutes to 1 minute to seconds, we multiply by what? 60. Because 1 minute is equal to 60 what? Seconds. Therefore 45 minutes will now be what? X. X is now equal to what? 45 times what? 60 seconds. That's what we got here. Now let me clean down again. So the quantity of electricity is what? 0.5 ampere times 45 minutes times 45 times 60 seconds. So at the end now we have that quantity of electricity here is equal to what? 0.5 times 45 times 60 what? Coulomb. So if you multiply this now, we'll have something like this. This times this, 0.5 times 60 give us 30. 30 times 45. Okay, we can just say 3 times 45 is 135, right? So this is something as 1,350 what? Coulomb. 1,350 coulomb. So there are the quantity of electricity that was passed through the electrolyte is 1,350 what? Coulombs. So let's continue. Having established that, we need to find out the mass this 1,350 coulomb can deposit. That's where the question now comes. but it's simple. We can use it to set up a proportion with this. Well, we have already known that 2 times 96,500 coulomb deposited. Okay, let me bring it down a bit. This 2 times this is 0.001 0.001 12 13 carry one put here 18 19. So 193,000 coulomb will give us what? 64 gram of what? Copper. So if 193,000 coulomb of electricity deposited what? 64 what? Gram of what? Copper. Now 1,350 coulomb will deposit what? X. We don't know. So we solve for X. Let me clean up here. So we do what? We solve for what? X. That means that X is now equal to what? We must multiply 1,350 coulomb times 64 gram over what? 193,000 coulomb. So this, you cancel this. So in that case, what will happen now? Let's divide this. Rule out the 0. Clean this in well. So what will happen now? Let's continue. This is jam, no calculator. So we'll do it without calculator. So let's go. So what we go now? Let 5 go. 5 go here. We have what? 13. We have 2. 2. Remember what? 3. You put it here. 35. We have 27. What? If 5 come here, goes here. We have what? 19. We have 3. Remember 4. Put 4 here. 43 divided by 5. We have 8. 8. Remember what? 3. You put it 3 here. 30 divided by 5. 30 divided by 5. No. 3. Carry 4. Put here. 43. 43 divided by, we have 8. Okay. Yeah. 30. We have 6. Bring down here. 3,860. So we'll continue dividing. So what will happen here? We have our, can 3 still go? Or let's try 9. So okay, let's multiply out and divide it as a stretch. So we have our 64 times 27 will give us what? 7 times 4, 28. Try to put here. 7 times 6. We have our 42 plus 2, 44. 44. 2 times 4, 8. 2 times 6, 12. Bring down 8. Bring down 8. 12. Carry one, put here. 6, 7. So we have 17. 1,728 over what? 3860. So let's divide out straight and see what we have. So if this divide by this cannot go, we put 0, add 0, then put decimal point, add 0 here. How many of these can we find in 17? Can we find in 17,280? If you multiply this by 3, you get approximately 3 times 3 is 9. Approximately 11,000 something. So let's move up to 4. If you multiply this by 4, let's see what we get. This is 0. This is 30, 24. Put 4. Carry 2. Put here. This is 8 times 4, 32, 34. Carry 3. Put here. 12 plus 3, 15. 15. So we have 15. Okay. The very one cannot be up to. So if you multiply this, if you subtract this, we have 0, we have 4, 2 is here, that one put here, we have 8, what many here? 16, 1. So 4 can go. 4 remainder 1,840. We'll keep dividing. We'll add 0 again. How many of these can be in here? We have already 4. So 4 can still come in. So let's subtract this minus 15,440. We have 0. Carry 1 put here. We have 6. 3 is many here. Carry 1 put here. 13 minus 4. We have 9. 1 is many here. 6 minus 7 minus 5. We have 2. So 2, we'll keep dividing. We'll add 0 again. 0, 29,600. How many of these can we find in here? Here alone we already have 4 here. For us to get 15,440, we already have 4 that gave rise to this 15,440. So, and if you multiply by 2, it will be more than this. So, I think 7 can go. You put 7. If you put 7 here, let's multiply this by 7 and see what we got. Let's multiply 3,860 by 7 and see what we got. 3,860 by 7. 7 times 0, 0. 7 times 6, 42. You put 2, carry 4, put here. 7 times 8, 8 is 8 times 7 times 7 is 49, plus 7 is 56. 56 plus 4 is 60. Put 6, 0, carry 6, put here. 7 times 3 is 21. 21 plus 6 is 20 what? 7. So we have 27,020. So if you subtract 27,020 from 29,600, we have something like this. At the end, let me come up, or let me come this side. At the end, if you subtract 29,660 minus 27,020, we have what? 0, 4, 6, 2. We have 2,000. So we have 7. Remember 2,640. How many? If you add 0 again, how many of these can we find here? It's still the same 7. So at this point now, let's stop here because we can approximate this. So if we approximate, let me clean up here. So we are getting, I'm getting what I'm looking for. So we are getting, at the end, we are getting that x is what? 0.4477 what? Gram, which is approximately what? 0.448 gram. So the quantity when in the electrolytes, when a current of 0.5 amp is passed through the electrolyte for 45 minutes, we are going to, what will be deposited at the cathode is 0.488 gram of what? Copper.